Greetings to Doctor. My name is Pravindra, son of Kannan, and my matric number ID is CE 210 and 202. So today I am representing the group number 4, which is from section 5, and it is group assignment. So the teammates are Jeevan Jaya Dayalan, Pravindra, son of Kannan, it is me, and Benjamin Ho. So without delaying, I straight go to the introduction. So the Taylor series expansion experiments functions and derivative numerically. The Taylor series depicts a function as an infinite accumulation of derivative at one place. This intention aids non-integrable or differentiable functions. Function derivative underpin science and engineering. They show a function slopes, conductivity, and rate of change. Complex function without analytical assertions might make a derivative harder to find. Polynomial Taylor series expressions estimates function and derivatives. The series can be truncated to experiment the function within a range. The expansion point closeness to the target evolution point and polynomial degree determine the experimentation accuracy. The Taylor series calculate derivative from functions and derivatives. Series group centers of the assessment point evaluating the function and derivative yields a local behavior based experimentations. Taylor series explanations linear term produce a function first derivative, quadratic word needed for second derivatives. Expanding to higher order terms experiments derivatives. So the below is the formula that is given.
For methodology part, the suitable method that we use is Taylor series. We're using the Taylor series for numerical estimate function and their derivative. He also obtained the polynomial approximation to function that capture their local behavior and allow us to compute derivatives at specified place. To calculate unknown values, this assignment combines the first and second derivative and Taylor series. Furthermore, MATLAB simulation software is used to test and improve the correction of the data. How we solve it? First, that we settle the manual calculation using the first and second derivative method. Then we use the MATLAB simulation software to ensure the accuracy of the calculation, whether it is correct or not. It is because MATLAB allows us to use matrix manipulation, plotting of function and data, implementation of algorithm, creation of user interface, and interfacing with programs written in other language. So now we're using the C programming language to program in MATLAB so that we can calculate in MATLAB by using C programming.
Selamat sejahtera and good day. My name is Jeevan Jaya Dayalan. My matric number is CE210092. And here I will represent my team to present my part. Here in general, the Taylor series can be derived in the system with the equation. So here I will show the first derivation using Taylor series. We have several equations here. So for the first equation is 2-point forward difference. We can see the equation here. Fx equals to f plus h minus fx over h. And then we can see for the second point backward difference, the equation is fx equals to fx minus fx minus h over h. And then the third equation is 3-point central difference, and the equation is fx equals to fx plus h minus fx minus h over 2h. And the third equation is 3-point forward difference. Fx equals to negative f bracket x plus 2h plus 4f bracket x plus 2h minus 3fx over 2h. And then the fourth equation is 3-point backward difference. Fx equals to 3fx minus 4fx minus h plus f in bracket x minus 2h over 2h. And the last equation for the first derivative using Taylor series is 5-point difference, which is fx equals to negative f in bracket x plus 2h plus 8fx plus h minus 8f in bracket x plus h plus f in bracket x plus 2h over 12h. Next, I will show the second derivative using Taylor series. So we have two equations here. The first equation is 3-point central difference for second derivative, which is fx, which is second derivative, is equals to f in bracket x plus h minus 2fx plus f in bracket x minus h over h square. And then second equation is 5-point difference for second derivative is fx equals to negative f in bracket x plus 2h plus 16f x plus h minus 30f x plus 16f x minus h negative f in bracket x minus 2h over 12h square. So these are the equations for the Taylor series. And now we have came to the most important part, which is the result and discussion. So here we go to the question, which is the demand for electricity is increasing every year. As electrical engineer, we need to find alternative way to save electricity. So we need to use other renewable energies to save non-renewable energies. As electrical engineer, I suggest we use solar power energy that we are using frequently on daily basis. As electrical engineer, we need to provide the projection of electricity demand growth by considering the economic parameters and so on. It is also needed to provide the solar generation capacity requirements to meet demand and ensure accuracy and security of supply by taking H value is equals to 1. Find the approximate value of Y prime 2016 and Y double prime 2016 for the peak demand actual from 2012 to 2016 and the projection from 2012 to 2021 by using all appropriate formulas, which is Taylor series for equation. So here we have managed to take the data of the solar energy that is used in Malaysia from 2012 to 2021, and here we have managed to do the table. Here we can see the table of solar energy capacity in Malaysia from 2012 to 2021. Next, we have came to the manual calculation part for the first derivative using Taylor series. So here we can see in the table I have put the x is on the 2016, and here we can see x plus h, which is on 2017, and x plus 2h, which is on 2018. Here we can see on the left side x minus h on 2015, x minus 2h on 2014. For the equation part I've discussed before, so now I will show the manual calculation. So for the 2-point forward difference, we can see here the calculation, which is f in bracket x plus h, which is this value 304. You can see 304, and then minus with fx. So this is our x 304 and divide by the h, and the h value was 1, so we can get 50. For the second equation is 2-point backward difference. So same, we can see we just plug in the value from the equation and we have made the calculation, which is 78. For the third equation is 3-point central difference. So we can see f in bracket x plus h value is 394. So and then minus with f in bracket x minus h value is 266. So 266, and the h value is 1. So and the value is 64. For the fourth equation, we can see here 3-point forward difference. We put the formula here and then we plug in the value from the data and we managed to get negative 0.5. For the fifth equation, which is 3-point backward difference, so same goes here. We use the equation of 3-point backward difference and put the value here. So here we can see x minus 2h. So x minus 2h value is 205, and then x minus h is 266, plus with 3fx, x value is 344, and divided by 2h, 2 and h value is 1, and we can get 86.5. And the last one for the first derivative is 5-point difference. We put the equation here and then we can solve it. So we have made the calculation, manual calculation here, and we managed to get 57. And that's all from me. Thank you.
Continuously, I am going to the manual calculation part 2, which is second derivative using Taylor series. So the table is already given from the question. We take the year is 2012 from the 2021. Also the capacity in megawatts is from 32 to 178. So the h is which is already given is h equals to 1 and the fx prime equals to 0. So for find the second derivative using Taylor series, the first formula we're going to apply is 3-point central differences, which is from the second derivative. So the formula, we just apply the formula first, which is f x plus h minus 2 f times with x plus f x minus h over h power of 2. So after that we just substitute the value of the x all. So because of the 2016 is our h, so this is our x, and this one is x plus h and x plus 2h, and this one is x minus h and x 2 minus h, and so on. So after we see the x plus h, we just substitute the 2016 values. So which is I elaborate the 2016 plus 1 equals 2017. So 2017 value is 394 and I just substitute all, and the final answer is I get negative 28. And same to the second one, the 5-point derivative. We just apply the formula which is given. After we apply the formula, we just substitute the formula with the value given. So for example, this is 545. The 545 is coming from the 2018. So 2016 plus 2 equals to 2018, which is 545, and so on. We just substitute and we get the final answer is negative 42.5.
So now I will present the MATLAB part that we can prove our answer by MATLAB. So this MATLAB, this is our coding. For the F, is the data. Then we choose the X is 5, which is 344. H equal to 1 means that every year we step 1 year and 1 year. Like this is 2011, 2012, like this. So we need to find the 2-point forward difference, 3-point forward difference, 2-point backward difference, 3-point backward difference, 3-point center difference, and 5-point difference is the first derivative, and 3-point center difference for the bottom one is second derivative. 5-point difference, which is got 2 comma, is second derivative. So that we can enter the equation, and here this FDF1 is 2-point forward, FDF2 is 3-point forward difference, then the BDF1 is about 2-point backward difference, BDF2 is 3-point backward difference, CDF1 is 3-point center difference, first derivative, CDF2 is 3-point center difference, second derivative, DF1 is 5-point difference, first derivative, and second DF2 is second derivative, 5-point difference. So we now please enter. We can show the data is same as our menu value. That's all for me.
So in conclusion, we can solve the numerical differentiation problem using both first derivative and second derivative using Taylor series. To prevent incorrect computations, we can use the MATLAB software to tackle numerical differentiation problems. Regarding our assignment, we are having some difficulty learning the MATLAB software to create our own coding to perform one mathematical numerical method. So we need to lend our time to explore YouTube for suitable coding to do so. They recommended that have more videos for understanding using MATLAB software, using especially for first derivative and second derivative using Taylor series. In practice, if the value of the function and all of its derivatives are known at one point, the Taylor series may be used to determine the value of the complete function at every point. That's all from me. Thank you, Doctor.